Okay, for our last example in the 1.5 notes, now we're going the opposite direction. Now, I give you the graph of the absolute value function, and your job is to answer some questions and come up with an equation. So let's start with some review from 1.2. I want to know when this function is increasing. So again, we always read our functions from left to right, and we trace it with our eyes, going up, 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 down, 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 down. So it's increasing on this up section. That up section on the x-axis starts forever to the left at -infinity, and it stops at this vertex point, which on the x-axis is +2. I'm going to be honest, I thought I was going to like this sparkly pen. I don't like this sparkly pen, so we're going to switch to a more calm color. Let's try this purple. That'll be better. When we say negative interval, we're looking at everything below the x-axis. So I've got this chunk that I'm looking at and this chunk. This first chunk that I see, again, starts forever to the left at -infinity, and it stops at the x-axis at 0. We put our union symbol to connect those two sections. This next section starts on the x-axis at 1, 2, 3, 4. And it goes forever to +infinity. Now I know that some of you are tempted to write -infinity there because you see this arrow pointing down, but remember we're looking at our x values. So even though this arrow points down on the y values, it goes forever to the right, meaning +infinity on the x values. So now when we look at range, this is one of the only times we look at our y values. Our eyes, the lowest point we see is an arrow pointing down to -infinity. And the top y value we see is +1, 2, 3, 4, oh my gosh, 1, 2, 3, 4, 5, 6. Hard bracket there. When we write x-intercepts, we want to write them as an ordered pair. I see two x-intercepts here, one at 0, 0, and the other at 4, 0. I'm just going to put the word "and" in between because it's not an interval, it's just two separate points. This limit represents one of my end behaviors. As my x's get infinitely small, or as my eyes move to the left, my graph points down forever towards -infinity. And finally, we're writing an equation. So when I think of our equation, instead of saying y, we called it g of x. So I'll say g of x equals. I could have an a value in front. I know it's an absolute value function, so I am going to have the absolute value bars. And I could also have a horizontal shift, and I could have a vertical shift. So my job is to fill in the values for a, h, and k if they exist there. Let's start with the h and the k. X is always going to be inside the absolute value bars, and remember we're just filling numbers in around it. Normally, my vertex is at 0, 0 for a parent function, but this time my vertex is to the right 3 spaces and up 6 spaces. So since I moved to the right, I don't actually think that's 3 spaces, that's to the right 2 spaces, I'm sorry. Since I moved to the right 2 spaces, that means inside my absolute value bars, I'm going to put the value -2. It lies to me. Then I went up 6 spaces, so at the end I'm going to put a +6. Now finally I need to figure out this a value. First of all, I know it's negative because it's a reflected graph, it's not a right side up v. And now I'm just going to find 2 nice points and count the rise over run between them. So for these 2 nice points, the rise is down 3 and over 1. I can double check down 3 and over 1 to get to the next nice point. So I would put a -3 out in front.